But this is kind of one aspect of this technology that's emerging kind of movement almost. And there are two things that we're kind of taking away from this. I mean, one is the technology, and that's exciting, and it's fun to think about, and it's helping us in terms of our research and what we do at the museum, and I'll talk a little bit about that. But then the other is this idea of community knowledge and kind of community development. And philosophically, that fits really well with museums. That's what we do. One of the main things that our goals are to get as much knowledge out to as many people as we can. So a lot of times we do that with our online presence, we do that with websites, we do that with our research and talks and that sort of thing, and as much as we can. And increasingly, well, 10 years ago it would be something where we'd write an article, or we'd write something for a magazine, or we'd give an interview to a media agency or something like that. Anymore, it happens in so many different ways, in so many different contexts. And so that's one aspect of this kind of movement that we're taking away from that, and kind of thinking about community-driven science and community-driven knowledge, and this idea of kind of reinventing the library. But then also the technology is something that we've been thinking about and doing for the last few months, certainly. My specialty is not in anything that's high-tech, like 3D imaging or 3D printing or prototyping or anything like that. It's in paleontology, in geology. The nuts and bolts of what we do is traditionally morphology, biology. I'm thinking about how animals evolve, not how do I get this computer to talk to this printer to make this kind of image, that sort of thing. So I'm learning a lot of this stuff the same way that you guys are learning. I'm learning it through YouTube videos and community forums online and that sort of thing. It's evolving so quickly that sometimes that's the best way to learn. Actually, most of the time that's the best way to learn. But the way that we're using this, we're kind of using it in a few different ways. Rachel over here is this is kind of a project that is being supported by University of Illinois Springfield. Dennis Roos is the department head of environmental studies out there. He's trained as a vertebrate paleontologist. This summer, he's also a research associate here at the museum. This summer, Rachel and two other students have been coming in regularly to look at cottontail rabbit bones from one of our Pleistocene cave assemblies in Missouri. But another aspect of that, Dennis had purchased this scanner a couple of years ago. This is one of those things that has kind of changed how we think about 3D imagery and 3D scanning anyway. Because this is something that's affordable enough that we could afford it. It's about $5,000 for the scanner and then all the accessories that it would take to actually scan something at pretty high resolution. And Dennis said, I got this thing. Why don't you put it through its paces, see what it can do, see what if it will work for what you would like to do with it. So I've been feeding them specimens all summer long. We've been trying to put it through its paces, give it all kinds of different bones, different specimens. We're doing everything from sculptures to fossils to that trilobite you saw. This particular thing that this morning, we scanned a dog skull from Modoc Rock Shelter down in Randolph County, Illinois. This is kind of an important specimen. It's an early dog burial. And came up with a pretty good three-dimensional model of it. But this is something that we can scan these, and then we can use them for research. Number one, I said morphology is kind of the nuts and bolts of paleontology. Well, we have a three-dimensional model of this, then all of a sudden we don't have to use calipers to measure single linear distances between points on the skull. You can look at points on the skull and compare it to other points on the skull between different 3D models. You can look at changes in shape. You can disregard size. You can completely normalize it so you don't have to worry about effects of size or something like that on this thing. So that's a whole emerging realm of biology called geometric morphometrics. one of the things that we can do with this. We're actually doing this a lot with dog bones. We started doing it with two-dimensional images, and we're finding that we can actually tease apart wolves from dogs, from coyotes, and a lot of things in between, and actually tease out some very subtle differences in bones that tell us about the behavior of these animals. So this is kind of one aspect of what is going on here. And then another aspect is, together with another research associate, Dennis Lawler, who's a retired clinical vet who spent his career at the Purina Research Animal Colony down in St. Louis. He's been coming in a couple of times a week to think about the pathology of dead animals, essentially. And so he's been looking at some of these dog remains to look at the bone pathologies on those. He's been looking at, well, in this case we have two ankle bones from elephants. We have one from a modern elephant from the Brookfield Zoo in Chicago, just to show you what a normal elephant, a straggleus or ankle bone looks like. And then the other one here is one that Jeff excavated in 1968 from the Boney Spring site in western Missouri. This is a mastodon straggleus. At one point there was a researcher that came through here, and he was a pathologist from the University of Kansas, looked through our collection and saw these holes on this bone on the front leg, and said this is something that's really diagnostic of tuberculosis. And he was able to see this diagnostic damage on lots of mastodon bones from collections throughout the eastern U.S. And he wrote a paper on it. He said, well, we think that tuberculosis was here before people got here. This is significant to the evolution of the disease. Really, tuberculosis in and of itself is kind of a recent disease. It's only been around for the last 20,000 years or so. And so having this here before people got here is kind of important in terms of thinking about the evolution of that disease. It's still important today in that about a third of the world's human population has tuberculosis. In fact, it's on the rise in places like East St. Louis. So, I mean, just around the corner. It's kind of a very real problem. So we had this, we wanted to take a closer look at this. We took it over to the U of I Vet Services facility in Champaign and got a CT scan of this and a couple of other specimens. In reality, what you see when you start looking at the internal structure of this bone is that you've got these holes, these cavities on the outside, but they're being fed by little tubes from the inside, little cracks in the bone. And so we sent those scans around to a lot of consulting veterinarians, ones that deal with larvae, deal with elephants, deal with just big animals. And by and large, all of them said, well, none of them said it was diagnostic with tuberculosis. Most of them said it was probably some sort of microtrauma that happened to this animal that was then exacerbated by some sort of blood vessel death, some sort of trauma that bone kind of remodeled around that trauma. So probably not tuberculosis, but that's one of those things to know. But that's kind of some of the research that we're doing. There's a three-dimensional model up here. This is all these models. We basically got the CT scans, which are a series of stacks of two-dimensional models that would be so thick. And then we used open source software, just like Joe was talking about, to create these surface models and then to manipulate them and to be able to see them. So this one's over here. You can actually spin it around. You can zoom in and zoom out and kind of see what we're talking about when we're actually talking about this bone right here. So that's one aspect of this. Another aspect is, well, in 2007 we were doing work in a cave up in southeastern Minnesota and came across kind of a significant fossil. This is a saber-toothed cat, one of the very, very few from the Midwest, and the only one of this particular species, Homotherium. This is a scimitar-toothed cat. In other words, there's a complete skull around the back here, steak knife kind of shaped canines, and it's different from the saber-toothed cat you normally think of. That's kind of a range of tar pits, where it has very long dirk-shaped canines. But this one is kind of a longer limbed cursorial predator. This is, we wrote it up. We were able to get DNA out of it. We were able to date it. It's about 30,000 years old. It's, so it's kind of a significant specimen. But the thing is, the person that owned the cave and the person that would subsequently own the fossil decided that he really wanted it to stay in Minnesota. And so rather than donating it here to the ISM, he donated it to the Science Museum of Minnesota. So it will be going up there after we're finished with it. Obviously, we're not finished with it. But despite that, since we did all this work on it, I wanted to retain cast here in the collections. While it's nice to have a 3D digital model of things to kind of consult and kind of archive, there's really no substitute for a physical model that you can put on a shelf. That physical model will be there in 100 years, whereas the software that we can see this computer file will probably only be around for another 5 to 10 years. You'll have to upgrade to something else. And if you miss one upgrade, then you're really in trouble. So if you think about how many times you have to upgrade your Windows system, every other year or so, otherwise you're just totally out of date. It's kind of the same way. That's a lot to trust to for the next 100 years in order to curate things. It's a lot easier and a lot more predictable to curate a piece of plastic. And this piece of plastic is kind of useful. It's actually incredibly useful. It's almost as useful as the original fossil. We can still take measurements off of it. We can scan it again if we wanted to. It's pretty accurate. So that's part of what we're doing with this. Where are we going with this? Like I said, we're into community knowledge and getting the knowledge we have out into the world and getting it out so the public can appreciate it and understand it too. And so we're thinking in terms of, okay, how do we go from this and that and get those into places where you guys can play with them and you guys can see them and learn from them and see what's in your backyard and potentially hold it in your hand because you finished your own model. And so that's where we're going with this. I was on the phone with a company up in Milwaukee that makes CT scanners earlier in the week, and I had a hard question for them. I said, we're thinking about kind of a digitization project where we create 3D scans of fossils. We have a whole bunch of really important fossils from the Mississippi Valley that are kind of half prepared, so they're crinoids and racopods and things like that are type fossils, so the first described fossil of whatever species that is. And they're important from that respect. They've been in the museum for 150 years. And my question to them was, if we scan those with your CT scanners, can we remove that rock and then create these kind of digital models that you can spin around, you can zoom in on some of the important parts of the specimen, see those diagnostic elements in that critter, and be able to see not only the pieces that are visible on the original specimen, but see more. So if they're prepared in a slab where you have a slab of limestone, and then you can see one side of that fossil on top. We scan it and we process it, we can actually remove the back side and see the side that is incorrect. So that's where we're going with this. And not only doing that, but putting him up online, putting him up on our website. It's something that you can download the file, you can spin it around and see it in the browser, and so you can actually learn from it when you come to your own home. So getting our collections into your brain is kind of where we're going.